Okay, first thing I just wanted to talk about the schedule, where we are. You can see I'm back home, which is good. Better light. I can see the screen better. Life's good. It's good to visit the parents, but it's good to come home. Okay, so the schedule, what's coming up? So we had the midterm this week. We covered recursion. We're doing stacks. We did it yesterday. We're doing stacks again today. And then we'll have a lab tomorrow. Okay. Next week, we're going to talk about cues. I heard someone giving a reason of why English is hard to learn. This was their example. The word cue is a letter that has the entire sound, followed by 5 silent letters. Well, I guess without the S. Anyways, we'll talk about cues on Monday and Tuesday, and then we'll talk a little bit about searching, hashing, and sorting. That'll be next week, with again a lab on Friday. Okay. And again, next week, I have to have some dental surgery on Monday. So Monday and Tuesday for sure will be pre-done videos, probably be out this weekend about covering cues. Okay. Probably one video covering all of what I would normally do on those days. I'll cover the entire chapter on cues. Okay. Wednesday, I should be back to normal, but I may still be talking funny. So we'll see. There could be a video on Wednesday as well. Thursday, I should 100% be back, I would guess. And I'm going to be around. I just may not be able to speak as well as normal. So I want to make plans just in case. Okay. And then we are somehow to the last week of class, which is crazy. Data structures is a lot to learn in a very quick time when you take it during the summer. Okay. But this last week we'll do binary trees and B trees, which are another kind of tree, and then graphs. Okay. And then we'll have on that Thursday will be the final review, catching up kind of stuff. And then the final exam will be on Friday. Okay. Any questions about the schedule and where we're headed? Okay. So the next thing is I have to find my iPad that I packed somewhere. So let me find that real quick. It was super quick, luckily. Okay. So again, we're to review where we're at. Hopefully this will work better than it did yesterday. Okay, so we're again talking about stacks. And I have to get closer to that. So the basic idea, it's still being slow. That's really weird. Yeah, I don't understand that. It's never been an issue until just today, because it's not showing an update. I don't know if it's a new version of Zoom or a new version of what. So I don't know what to do about that. Well, I've got a chalkboard handy, but no chalk. I guess now it's caught back up. I don't know why the big delay. Let me try actually to direct connect it. See if that fixes that problem. So now I should be able to share via cable. Okay, see if this is better. Okay, so again, we're talking about stacks. This looks better so far. The idea being we're going to have some number of elements. We don't know how many. All we can access is the first one, okay? So then all of this becomes hidden. Okay. So when we're looking at the operations that we've defined, we can look at this first element, okay, return that value with the top command, okay? We can remove that value with a pop command. We can initialize, which is going to wipe out what's there, okay? We can have some Boolean functions. Is full, it's full stack, but you get the idea. It is empty. And these are in particular, we're going to talk about this today. These are in particular to array-based stacks, okay? And we've also got a push to add new elements, take some element to add to it, okay? And then maybe a couple others. We have to do the copy constructor and reassign the assignment operator, all that, okay? But the idea is, you know, if we have, for example, the following code, so we have a stack, we're going to call S, okay? If we do an S dot push, so we initialize the stack to begin with, okay? So we have the pointer that points to nothing, points to null, okay? If we push a 5 onto the stack, then the 5 is going to be here. That's what our stack top, that's what they call it, it points to, okay? If I do an S push of 7, okay, now that gets pushed down. The 5 is there, the 7's there, okay? If I would see out S dot top, okay, that would print out the 7. If I would do an S dot pop, the 7 goes away and the 5 pops back up, okay? And then again, if I would see out the S dot top, it would print out the 5, okay? So that's the basic idea that we're working with, okay? And the way it implemented in arrays, I don't think I could do this as much as I wanted to because my iPad was not cooperating, okay? That this 0 position, okay, we're going to start pointing to that. So we're going to have the stack top is not going to be a pointer at all. It's going to be a number, okay? So the stack top will be a 0, okay? That's how you know that it's empty, okay? And then as you add things to it, it's, so again, if we did our push of a 5, the 5 is going to go there. And then the stack top would be equal to 1, okay? So we're always going to have to go back 1 to get things. If we pushed a 7 onto there, the 7 would be there. The stack top would now be a 2, okay? And then any deletions work backwards from there, okay? And then we've already allocated this memory. So to delete it, we just set stack top equal to 0, and we're back to nothing, okay? This does have that max stack size, which by default sets it to 100, okay? So a lot of the copy things you have to worry about if they're different stack sizes. You can just assume they're 100 and life will be good, okay? But again, what this does for us is that it's going to take up, and again, stacks are homogeneous, which means they have to all be the same type. You have a stack of ints, a stack of floats, a stack of doubles, whatever the stack is, okay? But again, looking at our memory, we're going to have to set aside 100 times the size of our data, size of type spots in contiguous memory for our stack using an array, okay? Which if you're in a memory-rich, processor-rich environment, not a big deal, okay? But what if you're not in that environment? So what we're talking about today is the idea of using lists, linked list for this, okay? So with the linked list, you're going to create this stack object, an instance of the stack class we're going to talk about the code on, okay? It's going to contain a pointer initially to null. And the book does the null kind of like an electric round symbol. That's still not right. They get bigger as they go down. Kind of like that, okay? And then from there, once we start assigning variables, again, if we had one element there, it would go, this pointer would go to the first node in our linked list, okay? So there's a C there, okay? And then if we're going to insert something, okay? Well, let me do this memory thing first. So again, if the stack element points to here as the first node, it could then point to here and then over here and then whatever. It's the whole point we have of using linked lists, okay? So let's talk about how this works in reality, okay? So we have our, let's say we have a stack, our initial stack, it's going to just point the stack pointer. Stack top is now a pointer, not an int. it's going to point to nothing. Okay. But once it points to something, we create our first node there. Got a 5 in it, and right now that is a null. Okay. When we're going to add another element, okay, so that was our s.push, if the stack's called s, push a 5. If we do an s.push on a 7, let's say, okay. Well, the way we want to maintain this, and you really could, if you wanted, go a couple of ways here. You could add everything to the end, and that wouldn't be a horrible thing necessarily, but that is not really the normal flow or the most reasonable flow. So we're going to keep everything to the top. Okay. So when we push a 7 onto here, we're going to do just like we did, and we've done all this code already. It should already be in your accounts, right? We're going to add a new node as a 7. Point that. Actually, we don't do that. That'll be the initial. Okay. We'll then let this, whatever this new is, we'll let new node link be equal to stack top. So that points there. Okay. And once we've done that, we'll just reroute stack top, let it be equal to new node. Okay. And then we've created it there. Okay. So again, if we would add another one, do an s.push on 12. Okay. And I'm going to move these over some. Okay. When we're done with this, this would point to the 12, which would point to the 7, which would point to the 5. And that points to null. Okay. So that's what you have. Okay. And this matches up that all we can get to, actually I said you could do at the bottom, you couldn't, you'd have to do the pointers wrong. So just ignore that. This is the way to do it. Okay. Because stack top points to the top of the stack. Okay. So whenever we want to do a top, all we have to do is return the stack top dot info. Okay. No, that's not that's a member data. That's going to give us the 12 currently. Okay. And then if we do a pop, so a pop then is going to be the same as the delete from head. Okay. So a pop is going to be just taking the stack top. Okay. Will be equal to stack top link. And that should be one of those two. Okay. Which will set the stack top equal to here. And then this goes away. Okay, so that's the basic idea. So when we're using the linked list, again, there's no max size. Okay, at least not a hard size. There's always a limit. Okay, you couldn't put 5 trillion things into this most likely because you will run out of memory at some point. But it's constrained only by memory. Okay, we don't have to allocate it in advance. Okay, so at the same time, it's not fixed size. Okay, so we don't have that to worry about. Okay, there's no functions for is empty stack or is full stack. Okay, because there's no max stack size. Okay, so those are the differences. The other things should be more or less the same. Okay, we've talked about the push is an insert to head or insert at head. The top just views the first element, the stack top info. The pop just deletes from head. And that should be it. Should be the same basic ideas. Okay. So we're going to look a little bit through the changes that we make in what this is going to look like. But are there any questions about the theory of what we're doing? Okay, so if we don't understand this, then what we're trying to do is not going to make any sense. Okay, we okay on this so far? Okay, so I'm going to backtrack a little bit here. I'm going to go ahead and pop up the server window here. and I want to talk about the example 7.1 in the book, just to make sure that your code's working on that. Okay, so let me get this going here. Share my terminal screen. Make it a little bit bigger. Okay, so on this one here, I wanted just to take a look again at what we've got here with the stack ADT. Okay, and I'd said yesterday that we can use the same stack ADT, whether it's an array implementation or a linked list implementation, and that's not really correct because of the different things we're going to need. So we're going to have to do another ADT for today. Okay, but just to look at this one over here. And I'm blocking myself with my menu bar. That's always fun. Yeah. That's what I want, stack ADT. Again, this is just from the book. And again, I'm using the more command. More allows us to just to view a file. Okay. So this more command is going to show that we have in the stack ADT, there's just the public, they're all public. We have the initialize stack, which is a void function. We have the isEmpty stack, which is a Boolean, the isFull stack, which is a Boolean. We have the push, which is a void function. We have the top, which returns a type, and we have the pop, which is a void function as well. Okay. So when you're typing these in, and I do, as I mentioned yesterday, I do recommend that you type them in rather than copy them from someplace else, because I know, and I did that too, and that as a professor, you tend to get lazy about these things, but it was worth it for me to get a better feel for this by typing them all in. Okay, I was then able to compile them along the way and then catch all the typos. Okay, but looking for in particular for where the constants are. If you declare a function constant in the prototype but not constant in the implementation, then you haven't implemented that file. Okay, you've implemented something different. Okay, so let's also look here at the it's the mystack.h. Okay, so this one again, we have to put our little if not define here, define so we don't include it twice, and then make sure that at the end we're going to have that. In fact, I did that and it gave me an error. Okay, we're including the IO stream and we're doing the CAssert here. The CAssert again gives us the assert function, which you assert some logical condition to be true. If it's true, life's good. If it's not true, then it's going to stop execution of the program. Okay, and we're using namespace standard. And now we're here's the part where we are inheriting from the stack ADT. Okay, and note that even though it's a .h, we don't put that here. It assumes it's a .h. Okay, it may work for a CPP2, I don't know, but .h is the better way to go there. Okay, and then we're going to go through and implement all of those functions that we did before. Okay, the prototypes go first. Okay, and then we're going to go through, and again, just so we're clear on a little bit of C++ lore here, I have to put in this namespacing because I'm no longer in the class. Okay, so the class ends right there. So that's why down here, if not, this would be homeless, basically. I have to home it by saying stack type type, : : That's the namespace. That's how we know that this returns to the function that's up here. Okay, so I've gone ahead, we did some of these in class yesterday, but I went ahead and typed all of those in just so I was ready to test out things. Okay, they're all there. You can go through. Again, I'm using the more. Okay, and then I also did a version of, I didn't do the whole thing, but this EX71. Okay, and you want this example, it'll help you on the homework, but you also, it'll help you come test time. This is how we pull all this together, right? This is how we can write programs. So again, I'm including the IO stream, I'm including the mystack.h, okay, which is the implementation. Again, I can create mystack objects. I can't create stack ADT. And again, putting ADT in the name helps us out because we know right away that that's an abstract data type and it has to be instantiated, or has to be inherited, sorry, not instantiated. Okay. So once I have that, I'm including the bisect.h, that includes the ADT, so we don't have to worry about it including it here. Okay. So if I don't have to do the if not defined here because I'm not going to be including this anywhere else. Okay, so that only happens on a header file that's going to be included potentially more than once. Okay, so I can just go ahead and start. So in my int main, this is how I'm going to create a new stack of integers. Okay, so again, we're in the array based from yesterday. So the stack type int creates a stack, we call it stack of 50. So the max stack size is 50. This one has a max stack size of 50 as well. And the dummy stack I'm not going to end up using because it had you implement this weird copy constructor of some sort. I don't care about that. So this is what we're going to do. And this is the reason we're talking about this now, is that this shows the what you have to do with a stack. Okay. So I initialize the stack to be nothing. Okay. It should have been nothing anyway, but just to be on the safe side. Okay. We make sure that we're getting a new array and everything's good. Okay. Then I'm pushing a 23. That's now at the top of the stack. The 45. So that the 45 is now at the top. 23 is below. And then finally the 38's on top. Then the 45, and then the 23. Okay. Now I'm doing a copy stack is equal to stack. Remember, we're reassigning the assignment operator, the equal sign. So this is going to do it in a true deep copy. So we have two different versions in two different places in memory, not just a shallow copy. Okay. The reason I'm doing that is, so let's assume I don't do this. Okay. If I don't do this, and I'm going to go through this on the stack, okay, I'm going to say while not stack is empty stack, cout top, and then a pop. Okay. That will work. That will print things out properly. Okay. In fact, let's do that. Well, I want to do it because that gets confusing. But anyway, what that would do, that would delete your stack. Your stack's now gone. Okay. So going through a stack is destructive. The only way to move through it is to destroy it. Okay. If you don't want to destroy it, if you want to print it out, let's say you wanted to print this out and then add another one to it. I guess we could do that. So let's do this the wrong way. Okay. So we'll still have it there, but we don't care about it. So let's just say while not stack is empty stack. That is not right. Okay, then we're going to take stack dot top and then stack dot pop. Okay, we've done all that. Now we want to add a few new items. I don't want to print screen. Okay, so I'm going to do a stack dot push 15, let's say, and do a stack dot push 44. Okay. Then I want to copy it again, and I'm not changing the label. We'll still say copy stack, which is not correct, but you get the idea. Okay, so we see that we have our first stack 38, 45, 23, like we expect. Okay, but then the second time it should say the 44, 15, 38, 45, 23, but it doesn't. Okay, the point being that we've deleted that. Okay, so if I change both of these again to use copy stack. Too far. Okay. And the same thing down here. Okay, but again, when I'm done with this, as part of this process, okay, I'm going to have to do again where my copy stack is equal to stack, okay? Because stack has been depleted by this point. So as part of the print process, it's make a copy, go through each item, print, delete, then we're done, okay? Now this, if I've typed it in correctly, should give us what we want. And it does, okay? So this works properly. So whatever you're doing with a stack, and this is not just because it's, I mean, because it wouldn't be an array. The data is still there. The memory is still full until we close out and hit and run our destructor. It's just we don't have access to it anymore. There's no way to get to the second item in a stack except by deleting the first item in the stack, okay? So you have to make a copy of it if you want to maintain that data, okay? Any questions about that example? Okay, so let's take a look now at what it's going to look like on our abstract class on the stack ADT. Okay, so this is going to be the one that's linked list implemented. Okay, so I think it's important that I'm not sure what they name things here because these are two different files. So let's see what it's doing here. They've got the node they're defining. I'm not sure what they call that. I'm calling it stack ADT, but we already have that. Okay, so that's not the same. So let's just call this one, I'm going to copy this actually, because some of them may be the same, but it may not be. I may just be wasting my time. Copy the stack ADT.h to let's call this stack LL for linked list ADT.h. Okay. Okay, so for this one, we have to start with our struct. Okay, so we have this first, and then we're going to go into our struct on our node type. Okay, and that's going to have our type info, like always. And it's going to have a node type pointer to that called blank, like we did before. Okay, I think the book actually has where you can pull from the existing linked list stuff that you have. Okay, and then we get to our, again, template class type on page 416 if you're keeping track. Okay, then we have our class. Okay, oh, they're calling it something different. I may have to change that. Now see it, they're calling it linked to stack type. Okay. So, oh no, that's not correct. They don't give the whole thing. That's strange. Come on page 415, it starts off with the node, but then on 416, it goes and does the linked stack type without the virtual functions, which is very strange. And they're going to have that derive from the stack ADT. Okay. Well, that is the same one. That's strange. Okay, that's wrong. That's my mistake. I'm going to be curious now. I thought I read this morning, but apparently I was losing my mind. Okay, so what they're doing here. So let me try this one again. So that's what I want to copy. So I want to copy my stack to linked stack.h instead. Okay. This is going to be the linked list. Okay. And they're not putting in the if thing there for the stack type. They probably should be. Okay. But they're going to derive from this one, okay, and define the linked stack type. Okay, so let's see what they've got here. So they're including nothing, which is interesting. Okay, they go right from, they do the node type, which I just did, so I won't do that again. But we do have to define our node type here. Okay, and then we're going to have from this the public, so the class is going to be linked stack type, which also derives public stack ADT types. That's okay. Okay. And then we'll have to go through, and this looks more or less the same. Okay. The only difference here, so all of this is going to be there. Okay. And I guess the reason we can do this, okay, is because what's going to differ is the data, and the data is not defined anywhere else. Okay. The member data for the object. So let me go ahead and put this in here. I do need to have that there. Okay. So we're going to go ahead here and put in our, which I just did, template class type, struct node type, which is going to have our type info. And it's going to have our node type pointer. Link. Okay. And then we're going to go through, and all of this stuff should be the same. Okay, but everywhere we say stack type, we're now going to say linked stack type. Because we have to redefine the same things. Okay. So we have the initialized stack, we have the is empty stack, we have the is full stack, we have the push, we have the top, we have the pop. Okay. And then we have our linked stack type.
So is there no way to like go through the whole file and change all stack types to linked stack type?
There probably is. I'm sure I could do that, but it's short enough. I'm just going to go through this way.
Oh,
Yeah,
okay.
I will guarantee Emacs does it. The Emacs does everything, but the things I don't have to do often, I don't remember. But yeah, that's why I should have an Emacs cheat sheet. We all should, because it's very powerful. Okay, but some of this changes, right? The constructor doesn't take any parameters. There's no stack size here. Okay, so we're not going to worry about that. Okay, the same thing here. That's the other reason I don't do a mass change. I want to see it as I go along. Okay, so that's the copy constructor, which is going to do the same thing with the linked stack type as other stack. All that's the same. And then our destructor, we have the linked stack type there. Okay, so where before we had the max size, the stack top, which was the index in the array, and the pointer to the list that we're going to create. This time we're going to have, instead, in the private section, we're going to have just the node type pointer. Okay, so we've got our node type. A pointer called stack top. Okay, so that's going to be a pointer to the stack. Okay, and then we also have our copy stack function here. Linked stack type. That should be the same as well. Okay. And then the rest of that, we're just going to be going through and implementing these. Okay. So let's look at just a couple of these. Okay. So we can start here with the initialized stack. No, we'll go back to that. Well, actually we can, the initialized stack. there's a little bit more to this. Okay, so let's take a look at this one. And I'm on page 419 here now. Okay, and again, all of these do need to say linked stack type, or we get all kinds of errors. Okay, but the initialized stack, we have to start here with our node type called temp. So we're doing a pointer called temp, which is a pointer that's going to delete the nodes here. Okay, now I'm going to do a while stack top not equal to null. Okay, so while there are still elements in the stack, again, we're initializing the stack. Okay, we're going to go through and we're going to set temp equal to that stack top. Okay, then we're going to set stack top equal to stack top link. I'm going to delete temp. Okay, so again, we're putting a pointer called temp to the top of the stack. That's all we can see. Okay, we're going to copy that, copy that to temp, move the pointer of the stack to the next item. Okay, in this case, the next node. Okay, we're then going to delete that. Keep doing that until we get to empty. Okay, so that's going to initialize the stack for us. It's going to get rid of all the nodes, and this is going to clean up itself. It's going to clean up the memory as it goes along. Okay, so that's going to change for sure. So we've changed that one, a little more complicated there. The isEmpty stack is pretty straightforward here as well. We're just going to say not stack top is equal to empty or 0. We'll say stack top equal to null. Okay, if stack top is equal to null, then we know that we're dealing with an empty stack. Okay, the stack full doesn't make any sense for this. Okay, but we want to keep the ADT the same. We have to implement something. So the question here is, when is a stack composed of linked list full? It never is. So we're just going to return false. That's all that does. Okay. So now we look at the push. Again, the push is going to be where we're going to, in essence, do an insert at top. Okay. So none of this is going to make any sense. Do it a different way here. Okay, so this is basically an insert at head of the linked list. Okay, so for that, as always with linked lists, and again, this is good review for us for our linked list stuff. Okay, we're going to create this new node. Okay. For the new node, we have to, okay, we've created the new, sorry, there's 2 steps. I always forget the second step. We've created a pointer to a new node. Okay, we now have to actually allocate the memory. Okay, that's what the new node is equal to. The new keyword does that, node type. Okay, so just like if we were doing a pointer to an integer, we would have to declare the pointer to the integer, and then we would have to use the new keyword to allocate that memory. Okay, so now we have a new node pointer that actually points to some place in memory. Okay, and now we know from this new node that we're creating, we have to set its info. Okay, that's what we're sending in. So we've got the new node info. It's going to be equal to the new item that we're sending in from the parameter list. Okay, and we know for this new item, it's going to point to the old stop at the top of the list. Okay, so the new node link is going to be equal just to stack top. Okay, and now we want to reroute things and let the stack top is now going to be equal to the new node. Okay, so again, this is exactly what we were doing before. It's the same idea when we're inserting at the head of the linked list. Okay.
You spelled stack wrong.
I am not surprised by that.
I
may
thought I was tripping for a second.
Yeah. Well, I find if I type the same word too often, it starts looking like it's spelled wrong. So that's a different issue. But that was just a typo. which is odd because whatever I typed is not anywhere near the correct letter. Yeah, it's funny how your fingers go crazy sometimes. I may have told you once, my daughter was taking a typing class and they had a typing test to see how fast you were typing. And I've typed for a long time. And I was getting over 300 words a minute, but with a high error rate. So I'm not always, I go really fast. I'm not always accurate. Okay. So, so yeah, we've got that one, how that's going to work. The top is a little bit different, but not too bad. So again, the top, again, we have to assert this time that it's not 0, it's null. Okay. So assuming that it's not null, we have something there. But so what's at, there's no list at all. Okay. But we're going to return the info that stack top points to. Yeah, again, I did more typing before I did a G++, which I told you guys not to do. So I had a whole bunch of errors I had to correct. It's easier to do one at a time. Okay. So in other words, that's more or less the same way, not too much different. Okay. So with the pop operation, what it's going to do basically is delete from head. Okay. So we've had that before where it's just going to point now to the next item. Okay. So it's going to make a temp that points to the top element. Then it's going to make the, and we use the temp so we can delete it. Okay. We wouldn't have to do it to work, but to clean up the memory, we did. Okay. And then once we have moved the stack top to the link that stack top used to have, it's now pointing the correct space, then we can delete that temp. Okay. So to see what this one is, again, it's going to look a fair bit different because of the implementation. Okay, so I'm going to start with this one with a node type temp. If you weren't clear on pointers before this class, you will be by the end. So as long as it's not equal to null, okay, or we could have said, we could have used the not empty function, but we're going to do it this way. Okay, we're going to let temp be equal to the stack top. Okay, so we're now pointing to that so we can delete it here in a minute. Because if not, as soon as we do this, stack top is equal to stack top link. As soon as we do that, we've lost the stack top, what was stack top, the top of the stack node before, we would have lost. Okay, but we didn't because we kept it. Now we can do a delete on temp. We've cleaned up our memory. Okay. And then we've got here the else. We're going to see out that we cannot remove from an empty stack. Okay. So that's going to end the pop for us. Okay. And then again, the copy stack function, it's in the books. We're not going to spend time going through that, but it's going to be different, again, based on the idea that we're using linked list, but it's a fair chunk of stuff. Okay. The constructor is going to change as well. Okay. So for the constructor, let's see, where is the constructor? Let me find the constructor. That's the copy constructor. That's the destructor. Where's the regular constructor? That's really strange. Yeah, they don't have a constructor there, which is odd. They talk about it, but don't have it. Okay. So the copy constructor is just going to take another type, okay? And it's going to set the stack top equal to null and then use that copy stack we've already implemented, okay? So it's going to reuse that, but it has that special type. It overrides the constructor for that type, okay? In the same way that the destructor is just going to call the initialized stack, Okay. So you may think, well, why do I have basically two functions that do the exact same thing? Okay. The reason being is the destructor is a very special named function, right? So it's the name of the function or of the class with a tilde in front of it. It's called when the object goes out of scope. Okay. So it's called at a particular time. Okay. So we can't call it at other times. And there are other times we've already seen we want to run the initialize stack. So we have an initialize stack function. Then we also have where it's going to become the constructor as well, in essence, by calling that function. Okay. There's the other stuff in there on overloading the assignment operator. Again, you'll need to type through all those one by one. And then we get to example 7.3 where we're using that stuff. Okay. So that finishes up the stack using a linked list. Okay. There is another way that it gives you at the end on a stack as being derived from the class unordered list, because some of that stuff is in there. Okay. And that's a short little section that it's summer. Let's just not worry about. Okay. So that page 246 at the bottom and 247, you can look at that if you want, but I'm not going to test you on that. Okay. There is an interesting application on the postfix expression calculator. Okay. So it's what's called reverse Polish notation, which is an interesting thing to do if you haven't done this before. And it gives the example here. If the expression that you want is A plus B times C, the postfix way to do that would be A, B, C times plus, okay? Which is really weird. In a different world that probably none of you were alive for, Christy's the only outside shot at that, but I don't think she's there. It used to be that the HP12C calculator was the gold standard for any kind of financial analyst. They cost $600-$700. They were a little handheld device, and they used reverse Polish notation. And what it allowed in the days before, I mean, there were PCs certainly, but they were not the everyday calculator that they were before. And these calculators were a holdover from when computers were not readily available to people except on a mainframe. You had to hire a programmer to do that. So these calculators allow you to do super complicated mathematics in a fairly straightforward manner. And again, if you wanted to add 2 plus 2, it would be 2 enter 2 plus, which is just weird. It's a weird way to go. But I remember when my first job, I was lucky enough to get promoted pretty quickly from an actuarial technician to a technician to a senior actuarial analyst in just a couple of years. And when I reached that senior analyst level, they make kind of a big deal of giving your own HP12C calculator. So it used that reverse Polish notation. Okay, so it turns out to be super useful in a lot of applications. Okay, but this is an example of how you're going to push the things that you're typing in onto the stack, and then you can pop them out, and it avoids the whole problem of the order of operators. Okay, it makes it real clear. So no parentheses are needed. Okay, so it's certainly worth looking through that. I'm not going to make you type all that stuff in, but you certainly can look at that as an example. Okay. There's another example there on removing recursion and non-recursive algorithm to print a linked list backwards. You can go through that if you like. Again, nothing I'm going to really test you on. Okay. Kind of the last thing it does in this chapter, which again, we're just going to do kind of a quick hit on, is the standard template library class stack. Okay. So again, the stack is there. It's in the standard template library. You can use it. Okay, it's called stack, and it has the following operations. There's a size. There's an empty function, which is like our is empty. You can push an item. There's the top, and there's the pop. Okay. There's also the relational operators, the equals, for example, are there. Okay. There's an example using that on page 441. Okay. One thing that I will say that, you know how I watch a lot of YouTube on random things, and something that came up on my YouTube things that I should watch was someone doing a review of the standard template library for programming interviews. Okay. And they make a pretty valid point, because I've seen this before, that if you're applying for a job as a programmer, there's a 100% chance they're going to ask you to do some code. Okay. So that code, if it's in C++, you can save yourself a ton of time by knowing the standard template library. Okay. So like the guy says, if you're fuzzy on the syntax, it's going to take you forever to get through the code. You won't get done. If you have to recreate, a linked list or a stack from scratch, you're not going to have time. Okay, so just keep it in the back of your mind. If you're applying for a job that expects you to know C++, then you should have, and you should study and find one of these videos, study the standard template library and be ready to go with it. Okay. For many applications, it's exactly what you need. Again, in this class, we're not just doing the standard template library because we want the additional flexibility that you get from programming your own. And it's also the idea that we're getting a deeper understanding of the underlying technologies by developing our own. Okay. So if you want to understand how a boat works, build a boat. It's different than buying a boat, right? If you buy a boat, you have some familiarity. But if you build a boat, you know every single part of that boat. You know why it's there. You know how it's put together. Okay. So those are the two things that we're doing from that point of view. Okay. So you can look at that example. It'll be more useful to you when you get ready to go in the job search than it will be in here. Okay. So I'm not going to give you any examples on that as far as the homework goes. Okay. Are there questions about any of the stuff that we've covered today so far? Okay. So the homework was, I've got it on there somewhere, 1, 2, 3A, and 5, I believe. Okay. So go ahead and take a look at those. 5 in particular is going to be interesting when you're going to input an arithmetic expression and it's going to find out whether or not the program contains matching grouping symbols. Okay. So we're going to use a stack for that. Okay. That when you open one, you push it on the stack. When you close one, you pop it back off the stack. It's the basic idea that works. So that's pretty interesting problem. And that's kind of a lightweight version of the reverse Polish notation problem. Okay. So if you have all the homework problems done, then you're free. You can go off and live your life. But if you have not got those homework problems done, I would go ahead and look through those. Okay. None of those require the linked stack one. Okay. But I'll give you a heads up for the lab tomorrow. We're going to do the problem 2, which is doing exercise 1 again, but with the linked stack. Okay, so you're going to want to have that stuff typed up as well. Okay, I think it's also just useful to have versions of these data types that you have typed up that are working, that are ready to go. Okay, I think I talked with Christy, but not about everybody else. But maybe it was the whole class. I don't know. But it's certainly something worthwhile that if you don't have a GitHub account, to set up a free GitHub account, and you're going to want to put coding examples of things that you've done as you work on projects for classes, upload those. And the time to do it is now. We should, in our very first class, and I don't when I teach that class, and I should, we should go ahead and have students. In fact, I'll probably do that next fall. We should have our students set up the GitHub just to use as a place to put code that you think is useful. Okay. So when somebody asks you, have you programmed in C++? You have a list of code that you've done. Okay. That can be a useful thing. Okay. So yeah, I would recommend that as well as something to do. Okay. That's all I got. Anybody have any questions? So work on those homework problems if you're not done with those, and we'll come back at 2 o'clock if you have questions. If you don't have questions and you've already done them, then just get ready for the lab tomorrow by making sure you have the linked stack type stuff working, and you should be good.
So question 2 is off the homework then. It was listed on the homework.
Oh, was it? Was 2 on the homework? Well, okay. We'll do something else for lab. I'm sorry. It was 1, 2, 3A, and 5, wasn't it? Okay, so yeah, go ahead. So that makes more sense then. Go ahead and do 2 now if you haven't. That will make sense. And then if you have questions about problem 2, we'll talk about it too. And I'll find something else for us to do for lab tomorrow.
Just a reminder, I will not be here for tomorrow's lab.
Okay, that's fine. That'll work.
One day, can you do the GitHub thing with us?
Yes. Yeah, remind me of that again, and I'll I may have a video I've done on GitHub, but if not, we'll do it live.
Okay, and you can send your code straight from the Ludwig straight over there.
Yes.
Okay,
Yep.
cool.
Yep, you can post directly. It's basically what GitHub does. It's if you're working on a project, it's a place that multiple people. So for team projects, it's perfect. You can put versions of the code, and it's called commit when you make a change that you want there. You can then get back from the archive or the repository the current version of the code. So if all three of you are working on a project and Christy was up late last night making changes, well, Dylan logs on to start making changes he wants to make. He can guarantee that he has the latest version by downloading what she committed on last night. So that's how it works in a multi-purpose environment. But you can also just put your own code out there. Okay.
Okay,
And remind me if I don't think of it. We will talk about that again.
gotcha.
Okay. Anything else?
Yeah.
Okay, then work on problem 2. And if you have any questions, we'll talk about it at 2:00. And I'll see you then.